Hey guys, welcome to my tutorial of elementary calculus. This time I'll be just doing everything by pen. So this is the first video I've done by pen. Okay, so I'm just going to differentiate four functions using the power rule, product rule, and the quotient rule, and the chain rule. Okay, so my first function is y equals 6x squared, and we're going to use the power rule for that. So with the power rule, you multiply the coefficient by the exponent. Then once you've done that, then you subtract 1 from the exponent as well. So my dy over dx is 12x. So that's the first derivative, and you can also further differentiate that as well. So if it's going to be the second derivative, that'll be 12 anyway. Okay, and then my second function be y equals cos x times 2x. So here we're going to be using the product rule. So the product rule is du over dx times v plus then dv over dx times u. Okay, so u is going to be cos x, and then my du over dx is minus sin x, and then my v is 2x, and then my dv over du, over dx, sorry, my bad, is 2. Okay, so then we chuck in those numbers, those functions into our formula here. So we get so du over dx, so that's minus sin x, right, times the v, which is 2x, then plus my dv, which is 2, times cos x. So my dy over dx needs to go for that. Again, further, we can just factor out 2. So 2, then minus sin x times x plus cos x. Okay, so that's our final answer. That's the derivative of that function. Okay, so I'll go into the next one, which will be I'm gonna use a black pen. A third function will be e to the x over 3x cubed. So here I'm going to be using the quotient rule. So my u is e to the x, and then my du over dx is e to the x again. It doesn't change. And then my v is 3x cubed. dv over dx is equal to 9x squared using the power rule. Okay, so the formula for the quotient rule is so du times v over dx minus dv times u over dx over v squared. So what I need to do now is just plug in those numbers into here. Okay, so my du over dx is e to the x times my v, which is 3x cubed, then minus my dv over dx is 9x squared, and then my u is obviously e to the x. Then v squared is 9x to the power 6. Yeah, 9x to the power 6. Okay, then further simplify that. What I'll do is I'll factor out 3x squared times e to the x, so 3x squared times e to the x. Okay, and that will leave me an x here minus 3 over 9x to the power 6. Sorry, I just crimped space. Okay, then obviously reduce everything, like reduce everything. So so that'll be 1, that'll be 3, and x squared, so using your laws of indices, so that'll be, final answer will be e to the x minus 3 over 3x to the power 4. So that's the final answer. So dy over dx. That's using the quotient rule. And finally, or not finally, then the other one that I'm going to work on is cos x squared using the chain rule. So y equals cos x squared. So using the chain rule. So I'm going to assign AU is going to be x squared, and then du over dx is 2 to the x. Then y equals cos u. Then dy over dx equals minus sin u. So dy over dx equals du over dx, okay, times du over dx times dy over du. Sorry, I made a mistake there. Dy over du. Okay, right, and then I'll further simplify that. So it's 2x times minus sin. So obviously my u is x squared. Okay, and then just make it a lot neater. Minus 2x. Yeah, so that's the derivative of that using the chain rule. Then I can also do using differentiation from first principles. Right, differentiating from first principles. Okay, so let's say I have a function, let's say x squared. So y equals x squared, and differentiate the differential for that will be 2x. Okay. Okay, but then I can also use, like I was saying, the first principles. So that will be limit, and h approaches 0. It will be fx plus h minus f of x over h. Okay, and so substituting a value, so that would be so lim h approaches 0. So x plus h minus x squared over h. Okay, then what I'm going to do is I'm just going to expand that. So that will be so limit h approaches 0. So it'll be x squared plus 2xh plus h squared minus x squared all over h. Okay, and then so that and that cancel out. So that goes on to, so limit h approaches 0, and then 2xh plus h squared all over h. Okay, and then I'm going to factor out h as well. So lim it h approaches 0. So then h 2x plus h all over h, which further then obviously that cancels out, right? And then when h approaches 0, so that becomes 0. Okay, so then we're left with 2x, which is what we got here. So that's differentiation from first principles. Okay, so hopefully it was just a quick video, and hopefully it makes sense. So anyway, have a good evening. Thank you. Right, thanks guys.